Okay, hi everyone. This is hopefully the final part of our TDD/BDD series, where I will show you how I implemented the final steps of our test rig, step number 4, 5, and 6 here. But before we go there, I'll show you first how we made one fundamental change, right? To decouple our application from the authentication and authorization part by mocking keycloak. Okay, so where do we do that? Okay, right. So if you recall earlier, the first step, right, this given I am Jambala user blah blah blah, right, actually authenticates our application with an external component called keycloak, right? That component will return as a token that we can use for our subsequent calls, API calls, right? So, but that introduces a problem where every time we want to run our test, we have to ensure that keycloak is up, right? So in order to mitigate that, we will use something called KeycloakMock, right? So this is a library created by someone that I'm using for this demo. What it does is basically, if you look at here, right, KeycloakMock, yeah, you just declare this KeycloakMock, right, and then you start and then you initialize it as part of your init method in your test class, and you define the config that you want for the mock keycloak server. In this case, I'll set it to run with port 8000 and then with this default RAM. And then when we want to call, we want to get a token, we'll just say keycloakMock get access token, and then you pass the config for the token, right? In this case is what is our preferred username, realm, authorized party, and claim for our use case. Okay, alright, so let's get straight to step 4, right? Let's have a look back at this feature file. So step 4 says that when I transfer $1,000 from this account to this account, right? So this is a actual do transfer step. If we trace back our commit, right? So this is step 4. So what we do is we create the test first, as usual, right? This is the test. This test states that I transfer from this amount from this to this. We know we need a new API, so the API we call it transfer/intrabank, and we expect that this is a very straightforward test step, right? Transfer, expect the transfer to return success, so we just expect that the HTTP status is okay, right? That's the very basic step. So what we then do is we create the controller, right? So the controller is called v1 transfer. So sorry, this one should have a /intrabank, and to make it read, we return HTTP status not implemented, so it fails. I might have jumped the gun slightly here, right? Because I've created the service class as well, right? And but that's okay, I guess, because we by default we know that we always need controller and a service anyway. So I've gone on created the test class as well, right? That is supposed to assert that the response is always 0, but it's not because this is not implemented yet. Maybe I'll just split this into different. Split it right. Okay, so it's become clearer. Okay, right, and then the next step is to make it green, right? So to make it green, well, we know that this application is not going to be the one that fulfills the request end to end, right? That task of actually doing the debit credit ledger and all that stuff is actually a system further downstream that we will communicate with via ESB, right? So as usual, we need to create the ESB class for it, which is this transfer ESB. Same like the account ESB class, it's actually just sort of like a proxy to the ESB service, right? A simple HTTP call, RESTful call using REST template. This is the request, this is the request, yep, this one, and this is the response. Okay, so what we then do is we inject the transfer ESB into the service class here, right? And then we make the ESB call from there. So we also need to test it, right? So in order to test it, we start with the unit test first. We mock that the transfer ESB is going to do this and return us successful response, right? And because it returns successful response, transfer service also should return us a successful response with status code 0. We also mock it at the integration level, right, where we mock the actual ESP endpoint, right? When we call this transfer service, which is basically this endpoint, this ESP endpoint, when we call it, we should receive status code 0, description success. Okay. Yeah, and we return OK now, right? Earlier we were returning not implemented. We return the actual transfer response from the transfer service, and that makes our class success. So the other thing that I want to just speak about briefly here is this ESB converter, right? So this is because we need a way to map the actual ESP request and response to our services request and response. So we're going to use map struct for it. Yeah. To use map struct, just import these two dependencies, map struct and map struct processor, and use it like this, right? So this is a pretty straightforward case. The fields are similar between these two, but if you need something more complex, you can go and read at the MapStruct website on how we can do a more complex mapping between the destination and the source. Okay, so then we've passed it. The next step is to refactor as usual. So one thing that we did here is to actually make the ESB statuses as enum, right? So it's more readable. So for example, success has this as a status code and this as the description. Post error is this, and this ESB error, this and this, and so on. Yeah. Okay. Let's move on to step 5. Step 5 is where after we're doing the transfer, then we should receive a message saying this is successful, right? Okay. So as usual, we create the before that, I think this is actually there's a slight change, right? We have changed that this whole thing now becomes a constant, a message that is supposed to be tested against, which you can see here in the step definition file that we have this whole thing is a message, right? Okay, so we know that this step description is a bit tricky. This presents our first real design dilemma in terms of how the main channel of this application should be, right? So we're thinking maybe the main channel should be a mobile app, and the way that this message should be delivered to the customer or the user is via push notification. But since push notification is something that is difficult to emulate in testing, we will instead go with the assumption that there is a push notification inbox somewhere in the mobile app, for example, that the customer can go and check their notifications, right? Inbox that has notification. So the implication is that we immediately know that we now need a persistent state. Yeah, and to do that, we opted to go with a simple database solution, right? So we are going to use Spring DBA and H2 as the database. So if you look at this, right? Yeah, this is the test, right? The test says that we need to match the message. So what we will do is we will call this endpoint that returns a list of notifications, right? A list of new notifications, and one of the notification should have a message that is equal to the message that we are expecting. So we then implement the controller, right? In the green step, we implement the controller. So this is how the controller looks like. There is an endpoint called new. We get the notifications from the service, right? And from the service, we mock first. I think we mock first the notification. Yeah, we do. We mock it first with dummy, right? The first one is an actual dummy, and the second one is the message that we actually want to check. And we define the unit test also. So the unit test says that notification is not empty, and one of the notification, all of the notification has a customer number that matches our test customer's customer number. We then refactor this a bit, right, by adding a repository, right? We should query from the DB for the notification, so we use grab this repository. We add a new method called find by customer number, and the service calls this find by customer number to get the list of notification, and we mock the repository also inside our unit test. Okay, now this pretty straightforward, right? So here's the thing, right? This brings us back to step 4, because step 5 is actually not independent. It relies on step 4. So step 4, as part of step 4, there should be an event, right, that is triggered to create the notification. So the way that we're going to do that, the simple way of doing that is when we do transfer, after we do transfer, we immediately call the notification service to save the notification. That's the simplest way, just a simple method call. But we'll try to make this a bit sophisticated, right, by implementing what we call event-driven design. So what is this event-driven design? So it basically is something, a design, right? A design of architecture that is designed to make different parts of the application more independent, loosely coupled, right? So the way that we're going to do that is by I guess first we have to understand the components of the event-driven design. First, we need to have an event, and then we need to have a publisher that publishes the event, and then we need a consumer or a listener for that event that will do something based on the event that is triggered. So I'll show you that. Okay, so we'll refactor this, yeah. Refactor step 4 and 5. So like I said, we need an event. Okay, event. So this is the event. So for the purpose of this demo, we'll just use a simple Spring event, right? We'll use Spring event publisher, Spring event listener. So this is the event. The event is an extension of application event from Spring. It has an object called monetary transaction, right? That we will use this is basically a POJO lah. At this point, it's a POJO, right? That contains all information about the transaction. So if you look at monetary transaction, you'll see that okay, it has customer number, source, destination, payee, amount, and date. All the basic information for any monetary transaction. And then we need a publisher, like I said. So this publisher uses Spring's application event publisher, right? So what it will do is whenever this method is called, publish event is called, it will publish an event, which is this, right, that contains the monetary transaction. So this event publisher is going to be called from transfer service, right? So transfer service, what we'll do is we'll inject the event publisher in the service, and then we'll say if the transaction is successful, publish this event containing this, the basic information for the transaction. Okay, so to be able to utilize that event, we need to build a listener as well. So the listener is built as part of the push notification service. Push notification service will add this new method to save the notification, right? And then we'll add this method that is annotated as an event listener that will accept the event, right, and save it as a push notification with this format, right, the one that matches this. Okay, alright, so that's about it, about the event driven design. Pretty simple. So next we'll see how we can test this. So in the push notification service, right, we'll test the process transaction event, where we'll create a transaction event beforehand, right? We'll mock the creation of the event, and then we'll push it. We'll let this method consume that event, and we assert, right, that it actually saves the event as a notification. Okay. The next one will be step 6, right? In step 6, well, I'm not going to bore you with the whole refactor thing again, right? Because you by this point, I think you are very familiar with how it works. So the only thing that I want to show is this part, right? So this, if you guys are familiar with Markdown, you will notice that this is actually a table. In Cucumber, it's called a data table, right? But the question is, right, how do we actually tell Cucumber to read this data table as an input for the test step? Yeah. So to do that, we'll use this thing called data table. So if you see this step, how we translate it into the step definition, my transaction history for account number. So this is account number, this is account number. So this now gets mapped to this list of monetary transaction. So we can easily manipulate it. How it gets mapped into that list of monetary transaction is this, right? We tell Cucumber, right, that this is a transformer. We annotate it with data table type that maps this key value, right, as a monetary transaction object, right, that we build here. So as you can see, reference numbers is reference number, transaction type, and so on. So the only difference is today's date, where this is actually just a placeholder. We don't actually map this into our object. We actually format a new current date for that. Yeah. Okay. So to test this, I guess the rest is pretty standard. It's pretty standard. We do the green with dummy service response, right? And then we do red, we fail it, and then we do we make it green again with event driven design. So this is the second part, right, where if you remember earlier, we publish an event at step 4, right? So this is another listener or another consumer of that event, which is in monetary transaction service. So in monetary transaction service, there is a method called process transaction event that takes that transaction event, right, and saves it into the database. So we had one publisher, which is this tab, and then we had two listeners, which is this tab and this tab. Okay, yeah, this is just removing unnecessary stubbing. So that's all, I guess. That's the end of our TDD/BDD series. I hope we have all gained something from this, and it actually gives some idea on how we can implement this practically in our day-to-day development tasks. So just remember, testing last, or even worse, not testing at all, right? And expecting the QA to do the job for you does not actually make it faster. It will, if you think about it, will actually hamper your progress in the next tasks that you do, right? Because if you expect to do just coding and QA to do the testing, right? When you done the coding for task A, for example, when you want to move to task B, you will now have to switch context switching between task B, doing development for task B, and fixing the bug for task A, which is not very easy in the development, because when you're doing development, it's important to have a flow, right? If you get constantly interrupted, it means that you cannot work at a very optimal level. Yeah. So my message is test now, test frequent, and test while you do development. In the next series, so I will create a new series moving forward. We will see how we can execute or operationalize an end-to-end development model with BDD by making use of the usual tools that we use in development. So the requirements in Jira, the code in GitHub, and then how we trigger the CI/CD in GitHub Actions. Additionally, we'll also look at documentation, right? How we can do documentation that is always alive and up to date. Yeah, so that on top of having our tests as our documentation to document the behavior of our application, we also have supplementary document that helps people to understand further the design of our application. Okay, so until next time, thank you so much for your time, and I'll see you around. Bye.